Okay, this is our very first review of Unit 9. I believe that there is an extra review built into Unit 9 to kind of help us prepare just a little bit better than in other chapters. Just because like these problems do take a lot of diligence on knowing what work to show, how to show the work, things like that. Because they're really, as we began this chapter, there's very little actual math in this. A lot of it is just knowing how to write your answers and what's expected from your writing. So again, please pay attention to detail. How do you write your answers and how do you make your decisions? Okay. So in this very first problem right here, I see that we're talking about averages. And so I have the average that. I have an X bar. Ooh, I have an S. I have a 1%, and I'm asked, is this quote unquote too low? Oh, and I also am giving 9 motors up there. All right, so here we go. The average historically should be 0.8. My sample is showing that it is 1.1. Notice how I have an S, a sample standard deviation. So that means this is going to be a student's T, and I'm going to have to be using the T table. My sample size was of 9 motors, and my level of significance is 1%. And I want to see, is it too low? If you're concerned by what does too low mean, notice that 0.8 is turning into 1.1. Okay, so what does that mean? Okay, so right now the null hypothesis is the average is 0.8. Do we have enough stuff to say that that's incorrect? So I think 0.8, I think it's actually going to turn into 1.1. So I think the average is actually bigger than 0.8. Okay, so currently it is too low. The current guesstimation is too low. I think it should be bigger. All right, so alpha is 1%. And this is a right tail. Okay, because this has an S in the problem, this is going to be a student's T. This is going to be T is equal to X bar minus mu of S divided by the root of N. Parentheses would be around the entire top and around the entire bottom. All right, so T comes out to be 1.5789. So I need to now construct my p-value, and this is built upon the answer that I just got, which is a T of 1.5789. Again, to use the T table, I also need a degree of freedom, which is n minus 1. So this is going to be 8 in this particular problem. So I go to the T table, degree of freedom of 8, 1.5789. Okay, so degree of freedom of 8, that line right there. Looking for 1.5789. 5789 and 98. I don't think it really makes a difference. 89. So 1.5789, 1.57 is going to fall right there before the 1.59, 1.57. So it's in between 1.397 and 1.592. Okay, so it's in between those two numbers, 1.397 and 1.592. Okay, but since this is a one tail, we're looking for 0.100 and 0.075. Okay, so it's somewhere in between those two. All right, so making our picture, this is a right tail. Alpha in this case is 1%. And I see I have p-values of 0.100 and 0.075. They're both bigger, so my p-value is going to be larger. And I usually write the closer of the two. So, but they're both bigger, so it doesn't matter which one you choose. So I notice that my p-value is larger than my alpha. That means do not reject H0. That means we do not have enough evidence to say H1. What the heck are we even talking about here? H1 is that the average is greater than 0. Okay. That's the draw of a motor. So we do not have enough evidence to say H1. We do not have enough evidence to say that the average draw of a motor is greater than 0.8 amps. Okay, here we're talking about probabilities. So this is a probability problem. So right now it says that the probability of, I think we're students with jobs or something like that, yep, is 40%. So that means probability is 0.40. So Q in this situation is 1 minus P, and so that would be 0.60. We took a sample, and our sample size was 92 students, and of those 92 students, it said that 44 of those 92 have jobs. So the probability that I just showed is R divided by N, and so 44 divided by 92 is 47% of students have jobs. So we have a difference here. Okay, and we want a 5% level of significance to show, is it more than 40%? Again, if you're unsure what that means, is we are going from 40% to 47%. So I think the probability is going to be greater than 40%. All right, so null hypothesis in this situation is that the probability is 40%. And so our alternate hypothesis is saying, I think the probability is greater than 40%. We are using a 5% level of significance. And this is indicating that this is a right tail. So because this is a probability, we are going to be getting a z-score, which is a standard normal. And so z in this situation is p hat minus p divided by pq divided by n, and that part is in a square root. What you want is a parentheses around the top and around the inside of the square root. So this is going to be p hat minus p divided by the square root of, open parentheses, p times q divided by n, close that parentheses. Z-scores go to 2 decimal places. This is 1.53. From here, I turn this into a p-value. P-value is based upon the sheer answer that I just got, and that was a z is 1.53. You always look it up as a negative. Always look it up as a negative. So z of 1.53. So here I go to the z table and looking up negative 1.53. Negative 1.53. 0630. Okay, so what I notice here, oh, sorry, not to that point, I gotta draw a picture. This is a right tail, so the rejection goes on the right. This is alpha, and alpha is 5%. And here I see that my p-value is 0.06. 0.06 is bigger than 0.05. So the distance from the edge is larger. And so it makes it to the do not reject H0 part of the picture. So I notice that my p-value is larger than my alpha. That means do not reject H0. Okay, so that means we do not have enough evidence to say H1. But is H1 probability is greater than 40%? All right, we're talking about students with jobs, a student with a job. So we do not have enough evidence to say H1. Okay, last but not least, I noticed that in this problem, we are given a sigma. So this is going to be a standard normal. All right, so average in this situation is 7.1 with a standard deviation of 0.8. Switch this up. I'm sorry. Our sample average was 7.5. Our standard deviation in this case is 0.8. Sample size was 17 cups, and alpha is 4%. And we're noticing that is it quote unquote different from? 7 ounces. That means is not equal to, this is going to be a two-tail. All right, so the null says that the average is equal to 7.1. Alternate says that the average is not equal to 7.1. Is it different than 7.1? 7.1. So this is going to be, this has an alpha of 4%. And this is a two-tail. All right, because this is a sigma, this is going to be a standard normal. And the z is equal to x bar minus mu of sigma divided by the root of n. Put parentheses around the entire top and around the entire bottom. So the top, 7.5 minus 7.1 divided by the bottom, which is sigma divided by the root of n. 2.06. Okay, because this is a two-tail with a z, I'm going to have to double this p-value. Well, let's just see what it originally is. So z is 2.06. I looked that up as a negative. So negative 2.06. So negative 2.06. 0.197. And because this is a two-tail with a z, I have to do the work. So times 2 due to two-tail. So the p-value is actually equal to 0.394. Picture. I see that my p-value is 0.0394. 0.3 is smaller than 0.4, so its distance from the edge is shorter. 0.394. So I notice that my p-value is less than my alpha. That means I reject H0. That's in the rejection zone. And then I accept H1. And this is exactly what I say. All I have to do is interpret the symbols. So average. Okay, so all I in essence have to do is interpret this into symbols, or into words, excuse me. So we reject H0, accept H1. So we reject H0, which is the average again, coffee dispense or something like that. Yeah, coffee dispense. is equal to 7.1 ounces. So we reject H0 and accept H1. First symbol is the average. Second symbol is not equal to. Third symbol is 7.1. That's in ounces. So we reject the average amount of coffee dispensed is equal to 7.1 ounces and accept the average is not equal to 7.1 ounces.